All right, now remember when I told you about the axial bonds in cyclohexane? Well, they've got a counterpart. Remember those parallel lines I showed you? So if something's parallel to the equator, it's probably on the equator itself, and that's what we've got going on here. All these hydrogens, even though they're kind of skewed that way, you average them all out, basically everything here is on the equator of this cyclohexane. So we call these particular CH bonds, all of these ones are going to be equatorial. The ones that are sticking up 90 degrees away from the plane of this are axial. If you want to think about it in terms of a globe, these are the north and south poles, and these are the ones that are at the equator. All right? So axial is the poles, equatorial is the equator. Okay? You put all of those together, and you get something that looks like that. All right? So there we go. So this is, again, this is another way the book is showing you how to draw these things. I can't emphasize enough how much you should practice these. As a matter of fact, in your notes section, in your notes notebook, I want to find an entire page where you've done nothing but practice drawing chair cyclohexanes and the hydrogens coming off of them. Okay, trust me, it'll help you. Especially on a test, if I say draw one of these things, you want to be able to produce it as fast as possible. So, follow these rules or follow the instructions that I gave you on how to draw a cyclohexane. Alright? So, here's problem 3.7. I just want to illustrate this. Okay, so given the following partial structure, add a substituent to X to C1 so that it satisfies the indicated stereochemical requirement. Alright, so find out what the dihedral angle is in each. Alright, so here's A. Whoop. You've got the solution right there. Don't look at the solution, kids. Okay, let me do it this way. Alright, does that show up? Down here, where's my hand? I need to go a little bit higher. Hang on. Alright, one more click. There we go. Alright. So A, anti to A. Where am I going to have something that's anti to A? Obviously, anti is going to be in the opposite position. Remember the Newman projections. It's got to be lined up this way. So I've got something down here. The other one is going to be in that plane. I don't know if you can see that. Okay. So if this is going to be anti, these things have to be in the axial positions away from A. Both of them pointing in the opposite direction. So if this is south polar, these two are going to be north polar. Okay. B, something that's gauche to A on 1 or 3. If it's gauche, then it's got to be coming down in this position. So those are two equatorial bonds to A, right? If something's going to be anti to C3, right? So I'm looking at something on the X and C1. So if I'm doing something anti to C3, C3 is going to be pointing in this direction, right? How can I get something anti to C3 on C1? That's a challenge, isn't it? Because the only things that you've got going on here are up and out like that. Okay? So that's a little bit of a problem. You can't really have something anti to C3. However, you can have something that's also in the axial position on C1. One going up here, one going up there. And once you got those are going to be the 1-3 diaxial interactions I've warned you about. Okay? And gauche to C3, that one's actually easier because if this is axial, this one's coming out here. Now, I also want to ask you one thing. If I've got two equatorial positions, are they going to be gauche to each other? Are they going to be axial? How are they going to interact? Okay? That's a good question. So let me turn on the lights here in a second, and I want you to think about that. All right, so here are my cyclohexanes, and what I'm asking in this position is if I've got this one, so here's the 1-3 positions that the book was talking about, right? Am I going to be able to get something in the gauche position to this hydrogen? So this one's going to be sticking out over here, so that's H, okay? Do I really have something that can be in a gauche position to C3 from C1? Not really. But are these two things, are they axial? Are they anti to each other? Okay? So let me do it this way. Okay, I do it on the front. So this is going to be C1. So I'm going to draw something. So here's H going up, And here's H sticking out. Okay. All right. So where is, so this has to be a carbon over in this position. That's C1. In the back I've got C2. Okay. So C2, H, H, and that's going to be a carbon as well. All right. Where's C3 going to be? Obviously, C3 is going to be one sticking out in the back over here. Okay. Because I've got an H over here and an H sticking out in back. Now those aren't going to be completely anti either, all right? So it's kind of a hard question to answer. This is why I wanted to highlight that particular problem, okay? There is no really good answer to that. But now you know how to draw these things. Again, remember what I said. Find a page in your book, draw these things out.